Okay, cool. I can see myself now. Uh, hello everyone. Just as always, we are about to start. So before we begin, could you please tell me whether you can see my screen, whether is everything fine with sound? Just as always, please write down your pluses or just put some reaction on my message in live streaming channel. Okay, I can see some reactions. Cool. Thank you, guys. Okay, today we are going to review task 3 and task 4, namely, yeah, thank you. No need to tag me, I can see it, but yeah, okay. I am now 100% sure that everything is fine with connection, with sound and all other technical stuff. So we can finally start and proceed to review. Okay, so today we are going to review two tasks, namely Simple CRUD API and basic testing. We will begin with Simple CRUD API as it's the bigger one, and then we will proceed with basic testing. Unfortunately, there won't be live issuance for the next tasks about WebSockets for you this year, but assignment doesn't really differ from previous year, so I will share with you link from previous year assignment issuance. Okay, good. So let's proceed to Simple CRUD API. Just as always, I will quickly remind you assignment requirements. So you had to implement CRUD API. CRUD stands for create, read, update, delete, standard actions that you can perform on your backend. And you had to implement this API using pure Node.js. Plus, if you want to, you could use TypeScript. So you had to implement support for GET requests for all users, for specific user, for creation of new user, for update of existing user, and for user deletion. Besides of that, you should handle gracefully requests to non-existent resources, internal server errors, port which application uses should be configurable using .env file, and interesting things where that you should implement sorry, not you should because deadline is for submission is already passed. You had to implement two modes of running application, namely development and production. In development, you had to use watch functionality of NodeMon or TS Node Dev or TypeScript, or even you could somehow incorporate Node.js native watch functionality into your application. So the idea is that you change code of your application and application restarts. And production mode, you had to implement separated script for it. For this, you had to implement a bundling of your application using Webpack or TypeScript or some other available stuff. And only after a successful bundling, you had to run a bundle file. And also, you could implement integration testing for your API, not less than 3 scenarios. Example of scenario you can see here. Plus, for hacker scope, you could implement some kind of synthetic horizontal scaling of your application, where you had to run multiple instances of your server with one load balancer in front of them. So user interact with load balancer. Load balancer distributes requests across across your workers or child processes using round robin algorithm. And you had to implement consistency across them. What do I mean? I mean that if you create user on one of the workers, then you should be able to retrieve this user on another worker. So they should somehow share your storage layer. That's basically it. Okay, let's proceed to the review part. we have this application written in TypeScript, and let's take a look at the scripts part. You can see that we have different scripts, so all requirements seems to be implemented, and we can see that everything starts from index.ts or index.js if we are talking about a bundled file. So let's take a look at it. Okay, so here we have function main, which only runs server. Just as always, I left some review comments. Yeah, so pretty short and obvious comment. If your function main doesn't bring any additional value, like here, it's not even asynchronous, so you can just use function run server directly without wrapping it into extra layer. Okay, so our main function run server, so let's dive into it. Let's take a look. What do we have here? We have here a function that parses body of incoming message, which is abstraction of incoming request in Node.js. So here we do pretty standard thing. We parse body reading from request as it was a readable stream. Actually, it's a W stream and it has a readable interface. So yeah, we can subscribe to data event, and on end event, we know that we processed all the chunks and we have all the body parts. So yeah, probably if you worked with I don't know, maybe with Express library, or you have worked with Nest.js already, you have you already have something like this under the hood, but and you can just use something request body and you already have this JSON, but in pure Node.js it doesn't work this way, so you have to read body chunk by chunk. But okay. We also have functions for different responses, and we have run server function that checks request method and request URL and provides necessary responses based on what we have in request. And if everything is fine, it tries to get information through user repository. Okay, what comments do I have here? First of all, please don't forget that Node.js recommend to import core modules functionality using Node protocol. So please prefix your stuff with Node and this colon. Plus, this is not about Node.js, it's about TypeScript. If you import only type from some Node.js module, please use type keyword. I mean, use import type, and here you have only types, or you can import runtime available values together with types. In order to do that, you need to provide type here, and you can have some another runtime value. Okay, let's check what repository exports. Okay, it exports in memory repository class. So if we would need to import class, which is obviously runtime value, we import it without type keyword, and we import type with type keyword. It's a good optimization and can help you to save some resources, so feel free to use it. Okay, let me remove my changes. Okay, regarding these helper functions, first of all, I have a concern about naming, because function name should be not a noun, it should be a verb, as you remember. So I would suggest to name it somehow different. I don't know, maybe get invalid data response, or even better, respond with invalid data, something like that. And minor concern, not concern, just a suggestion. I would suggest you to use content type application JSON here and respond with object that contains your error message. Something like that. Yeah, you can see that here we have bad request status code plus your message. Why? Because if you will need to add some extra properties or change format, it will be easier to add one more property to your object and get it from there instead of I don't know, trying to extract it into text, trying to extract it from text, or trying to switch from text to object. So it's more complicated, so better to use objects. Plus, it's very good that you avoid magic values for error messages and do not duplicate it. But you can use similar thing for status codes. So you have a num for error messages, you can have a similar num for status codes. What else about this run function? Run server function. In my opinion, it has too much inline logic. What do I mean? It's not put into some semantically named variables, plus it duplicates some of its logic. Okay, so we have this multiple cases when we test request URL by some regular expression. We have duplicated the UID check. We have some duplicated responses. So probably it could be refactored into something like this. I provided a fixed implementation below. You can take a look how it might look like. So first of all, as I suggested, we can have status code enum, plus we can also have type for supported HTTP method, or we can we could have enum here as well. But in my opinion, enum here may be excessive, but it's really up to you. Okay, and we can abstract our types into interface route. So route has a method which it's assigned to. It has pass. Pass can actually be string or regular expression, where we need to have UID on the end of the pass. Okay, plus we can have handler for this route. And we can have abstraction over this send response function. So we can have only one call of write head with status code and content type application JSON. So this is the case when we have some data, and this is the case when we do not have this data. And we can have a more abstract handle error function. So we can check that if error is instance of specific error. Probably this could be custom errors as well. I didn't dive too deep into this, but anyway, you can switch error or error message or error name. To be honest, it would be better to have separated error for all of this. This thing comes to my mind now, but you got the idea. So you have a single place where you handle all the errors. Depending on what error it is, you use this send response function with different status codes and different responses. And in function run server, you have a list of your routes that implement a route interface. You can see that all cases are covered here. Okay, and after that you only create server and apply a dedicated route on request handling, and that's basically it. And also we have this server on error, server listen, all other stuff. So it could look like this. From my point of view, it's a bit more structured and contains less amount of duplication. But okay, this was only my suggestion. What should we take a look next? Let's take a look at the original function, and we can see that it uses user repository here. Let's take a look at it. Okay, user repository only extends in memory repository. Let's switch back to our student implementation. Okay, in memory repository is represented by a class which has a map for its items, And I remind you that map is API that was provided to us into ES 2015 version, and it's like object, but kind of better from API standpoint, and specifically dedicated for being dictionary and working like this. So we had methods for getting all records. We have a method for getting specific record by ID. Yeah, and from this point of view, storing records as dictionary is better than storing it as array, but storing it as array is also fine. Why it's better? Because we have better complexity of request of single user by ID. Okay, so if we would need to find the user in some collection, we would have O n complexity, but here we have O1 complexity, which is obviously better. And we have methods for creation of a new user, for update of existing user, and for deletion of existing user. Okay, can someone tell me what is wrong with this code? I want you to take a look at this interface repository. You can write your answers into chat. I will give you a small hint. It's related with T type and how we use it there. And it's not about get operations. Nobody knows. Okay, guys, I will give you extra hint. It's about ID. And about create. Still no one. Okay. Oh, we have someone typing. I will wait. I don't know where to answer. There's no point in this extension. Maybe you are right, but my point was not in that fact. Guys, ID had to be server-side generated, okay? It was explicitly mentioned in your assignment. So ID is unique identifier, it's string UID, it's generated on server side. Yeah. So if we have some functionality that handles CRUD operations in backend, we shouldn't allow client to change IDs of records. Okay. Backend owns all those entities. We provide user with a possibility to update some fields, but ID is unique identifier. It can be referenced in other entities, so it should not come outside of our backend. It shouldn't come from client. So here we have incorrect type because data transfer object for create and update methods shouldn't have ID field. We shouldn't expect it to be coming from here. And yeah, I forgot to write down comment fully. The implementation is incorrect. You can see that we set item into items map using item ID. So it expects that we use ID here. And if we will run this application, oh, sorry, npm run start dev, let's run it in development mode. You can see that server is running on port 4000. I will open Postman. Please give me a second. Okay, let's use this post API users. and we have body here, okay, we have some specific ID. I will copy it just in case. Yeah, all other stuff is totally valid. We have string username, we have number age, and we have array of string as hobbies property. And when we will send this thing, you can see that we have exactly the same ID that we set. And if we will try to get all the users after that, you can see that we have this ID here. And probably if we will try to update user with this ID and try to change its ID, let's try to do it as well. Okay, we have 9 on the end. Let's add 0 here. Oh, invalid user data. Okay. Maybe for update it doesn't work, but still, we can create a user with ID provided by a client. It's not correct 100%. Okay, so we took a look at in-memory repository and how it works. By the way, I have another concern about this .env file. We should never commit .env. I explained it probably previously. So instead, you should have something like .env.example, which has all your environment variables with some default placeholder, okay? And .env should be put into git ignore. Why? From my opinion, reason is obvious, because .env may contain some sensitive data like API keys, some secrets, passwords, whatever, and you do not want to put these things into your GitHub, because trust me, there are a lot of robots that are crawling through GitHub repositories, searching for your uh, exposed secrets, and they will use your API keys for, I don't know. If it's good if they will just use it for something not very harmful. So you should never include .env into Git control area. You should include .env.example instead, and have mocked values here. So here we store only port number, but still maybe in some cases it can be a vector for hacker attack, because if we do not know port, we don't know which port we have to attack. This is just a side note, but still. Okay, let's take a look at the main function. It uses user repository, and it also uses easy UID function. Let's take a look at what it is. Okay, we have this function which do this value is some type. Do you know how this function is named in terms of TypeScript? How do we name such functions that perform some runtime check and depending on it assign some type to the value? Please answer in the chat. Just a quick check on knowing TypeScript and its basics. I will wait a little bit more because someone is typing. Just in case I don't trick you, someone is really typing. We will have kind of interactive session today. Okay, it takes a bit too long to write down type guard. Likely I had no idea about name convention, but the signature of the function doesn't require to define value as value. Unknown and value is UID. Value UID would be enough. Yeah, but name convention, but the signature. From my point of view, everything is fine with naming convention. I'm not sure what you are talking about which function. If we are talking about UID, it's type guard because it performs runtime check. Okay, it checks that value is type of string, and after that, it checks that value satisfies UID regular expression. And if it satisfies, then we can assign UID type to it. And for this, TypeScript uses specific syntax. Value is some type. Okay, so it differs from our regular types assignment because if we have incorrect types, they doesn't guarantee anything in runtime. Here, if we have correct runtime check, we can be more, let's say, more assured that we have correct type. Okay, isUID function looks very good. No concerns from my side. What else? We took a look at this user repository and how it's implemented. Let's take a look at the user model itself. We have models folder. So we have a class user that represents our user. It has a constructor plus some static methods that works with user objects. In general, it's okay. You have DTO, you have static methods to work with instances of this class. I'm okay with that. Okay, can deserialize. I remind you that we apply this to stringified JSON, and here we check for here we check our data in runtime. So we check that type of user is object and is not equal to null. By the way, while I will talk about underlying code, could you please answer why do we need this check that the user is not null? Because if type of user is object, it shouldn't be null, right? Why do we need this check? While you will be thinking, I will continue. But I'm still waiting for your answer. Okay, I left a review comment here because well, ID should be server generated, and it's not just the fact that we accept all data from user as this and can mistakenly overwrite ID. It's explicitly expected in object that creates user, so it's not correct. And also, if you have this typecast here, user as user, probably you could use typeguard like for this isUID function. You could put all these checks, you could put all these checks inside of this typeguard, and then you could write that user is user. And it would be better from my point of view because anyway you perform runtime checks, so typecast is not necessary. You can be 100% sure that user is user after performing all this check. Yes, we have correct answer here. Yes, because type of null is an object as well. It's known bug in JavaScript. So that's why we need to perform a check for null separately. Okay, good, thank you. And we have this from JSON method, which tries to JSON parse some data and try to deserialize it. If it can be deserialized, it creates a new user. Let's see where we use it. Okay, we use it for post on API users from JSON body. Okay, and deserialize user JSON. Okay, good. We don't actually. I'm not sure that we use it somewhere. somewhere else. Okay, we use it in proxy users repository. Okay, then it's good to have it as static method. I thought that probably it shouldn't be static because it's not used outside of from JSON, but it's used. Okay. What else do we need to take a look at? We can take a look at error messages num. Okay, we can take a look at config file, which is responsible for getting environment variables from .env file. In general, idea of putting this functionality into single module and exporting object with readable values is good, but I have concern about syntax because this syntax looks like enum syntax. Well, when it's capitalized, when property names are capitalized, so if you want to use such syntax, you can use enum. I do not recommend it. We have computed enums, but still it's better to use object here. But if you will be using object, please just use lowercase. I mean something like export const config 2, something like that. And then you will be importing config and use import property from lowercase. Okay. What else do we have here? We have proxy user repository, which is used in multi-processes mode. But let's take a look at some functionality in runtime. Okay, first of all, let's change port. It should be 4001. npm start. npm run start def. Okay, server is running on different port. Let's try to, I don't know, let's try to get users. Okay, it works. Let's try to get to the unknown invalid user ID. Okay, maybe it's correct. Let's try to handle unknown road. This is not the resource you're looking for. Okay, not found. It works. Let's try to throw runtime error. Maybe in the place where we request all the users. Okay, throw new error. Oops, something bad happened here. And let's try to get all the users again. Yeah, users. Okay, we have internal server error. We have it logged, but our application still works correctly, which is how it was intended to work. Okay, good. Let's remove this error here. Okay, what else do we need to test? Let's try to run API tests. Run tests. Run test. Export default. It seems that it doesn't work on my machine correctly. Expected token export. Okay. Let's firstly check that I have correct version of Node. Let's try again. Now it works. Okay, it was about Node version, sorry. So all tests are passed, so we can assume that the API works correctly. If tests are implemented correctly, let's take a look at them. And let's switch to student view. Okay, what do we have here? We have here variables for server and port, and we use hooks, we use jest and we use as a framework, and we use hooks before all and after all for global setup and tear down. As far as I remember, Jest has a dedicated API for this, but we have tests in single file, so yeah, it's okay to put it into before all and after all hooks. And after that, we have make request function, which performs requests, parse body, etc., handles errors, and so on, and we use it in our test suite. But from my point of view, it's not correct, because you were allowed to use supertest library, which provides you with functionality to write your tests. The the next problem that comes with this solution is that if you have some custom functionality in your test suite, you should have unit tests, at least unit tests for this, because when your test fails because of your custom function, you don't know whether it's about your custom functionality inside of the test, or it's about it's about not passing tests and everything is fine. So please try to avoid using your custom code inside of test files and build some complex abstractions. You can use ready-made solution from supertest library, which is tested, which 100%, okay, not 100%, but most likely it works correctly, and you won't need tests for your tests. Okay, let's take a look at the test suites. You had to implement 3 test suites, which represent 3 test scenarios. Probably you had to have 3 separated nested describe blocks here. And here we have a test scenario from Node.js assignment file. So we get all the users, we then try to create new user, we try to get the specific user, update it, delete it, and try to get it again and expect not found status code. Design of tests and test content is fine. We check for specific properties. Probably it's a bit excessive, because you can check that response body is strict equal to specific object. Okay, we don't need to check for specific properties, we can check for whole property, whole object at once. But anyway, we check that we received correct response status. We could check for correct headers in response if it was important for us, and so on. But it would be really better to use supertest. Another concern is that you put server into SRC folder. So when I see some module.ts and some module.test.ts near it, it looks like it's unit test for this model. So probably you should separate end-to-end tests or integration tests from your main code. So you had to have I don't know, maybe integration tests folder outside of SRC folder, and or maybe inside of a SRC folder, but it had to be separated somehow. And you shouldn't mix your integration tests with main code. And yeah, don't forget about this node thing for imports. So there are no 3 scenarios, but what we can see here looks mostly correct. Okay, let's take a look at how we implemented dev script. We use TS node dev here, and with respawn flag, which should work correctly. Let's check it. npm run start dev. Okay, let's try to change some code inside of server TS. Maybe we will write some comment. I save it and it's restarted. Okay, it works correctly. Good. Let's take a look at production mode. We have tsc and then run bundle file. Probably I was not creating requirements that it should be explicitly one file, but I have written bundled file here. So I was talking about a single file. You had to make a bit more work in terms of configuration, but okay, it's not listed in requirements explicitly, but the point was to reduce space, and if we do just reduce the size of the bundle code, and if we will do just npm run start prod, we will have, at least we should have exactly the same structure as main code. Yeah, you can see that we have these multiple modules, and I wanted it to be a single module and probably minified, so we could see benefits. But okay, it doesn't break requirements. It still run from build. Okay. What else do we have? We have multi-script, and we have multi-ts or multi.js file. So let's take a look at it. Everything else is covered by review. Okay. Let's take a look at it without my comments at first. So first of all, we get amount of worker ports. So we get amount of available parallelism from operational system constant, which is correct. Plus we have function for round robin algorithm that will get the next number of port. Okay, it looks correct. And also we have internal server error handler here. So it's a bit complicated, but let's focus. First of all, we have imported cluster from Node cluster package. And here we have this cluster is primary check. We have our main process and we have child processes. So code that is written inside of primary process will be working here. This is that code, and if we are inside of worker process, inside of our child process, then this else branch will be executed. So we have a single type of code, single module of code for both primary and child processes. It differs from Node.js basics. I separated those files for you, but it can be in one file as well. So here we get a port for main process, our load balancer from config port. After that, we initialize user repository and we fork our cluster. We create child processes. By the way, we have method fork. Okay, we also have spawn sync. We also have if I'm not mistaken, we have this exec thing which comes from child processes, but cluster actually uses fork, but cluster is abstraction over child processes. So maybe you remember what child processes fork is about, how it differs from spawn sync, exec, or exec file. Let's maybe refresh it in our memory. Let's take a look at the documentation. Shame on me, I don't remember it. Exact names. Child processes. Yeah, we have child process exec file, fork, and spawn. What's the difference? And what is fork about? Okay, maybe it's not interesting because I already pointed you to Node.js documentation. In child processes, fork is used for specific creation of Node.js child process. So it can be using child processes, we can spawn new processes, not only Node.js processes, but we use fork for spawning of Node.js processes. Okay. So we get next port that we will use to send request to, and after that we create our load balancer server, and we proxy requests our from our load balancer to our workers, and after that we get a response from worker. So for each worker, we handle a message event from worker thread, and depending on what is the type of our event, we get data from our user repository on main process. And after that, we send this data back to main process. Okay, this code may look complicated, but it satisfies requirement about a single place where we store data, where we get our data. But to be honest, it looks really weird, and I left a comment about it. So let's take a look at this. So main process retrieves data from database on a message from worker. So mainly what main process does it just it pings our worker processes one by one, and after that it receives response from workers and gets data from repository. I mean, it just all the work with data is done. All business logic is executed on load balancer level, and then it sends it back. It's not correct. Why? Because we do not have complex business logic here. We have almost no business logic because we only perform simple CRUD operations. But imagine that we have some computational heavy business logic on our application instances. And in this case, we want to offload main process from this logic. Basically, what load balancer should do, it should be agnostic to our business logic. It should only receive request from client, send it to dedicated worker. Worker should perform all the business logic stuff, should perform all these heavy computational operations, and then it should send response to load balancer, and load balancer should provide it to client. It shouldn't perform any operation. So maybe I missed it in task requirements. This implementation is 100 incorrect, but probably if you will see something like that, you shouldn't deduct point for this because, well, we have child processes. It somehow interact with main process. We have single source of truth. So I can see that this functionality will work correctly on unit tests probably, but still it's not correct by architecture. Okay, let's take a look at this proxy users repository and why do we need it. This is the last file that is left. Okay. This is what workers use for processing of messages from main thread. So instead of making, let's say, instead of making our main process stupid, we made our workers stupid. which is not correct. It should be vice versa. So yeah, it processes messages from main process. It checks type of message, checks that we have request ID, which is actually a random UID assigned to request. It's good that we have it for requests. It allows us to easily find necessary log message in our log storage, for example, but still it had to be ID of the record. Yeah. And what else do we have? Basically, we send data back to data back to main process. Okay. Don't see many sense to look at this file, but overall it's interesting implementation, but not fully correct. Okay, probably that's it about this task. Maybe you have some questions, can answer them, and then we will move on to basic testing task. I will wait for about 1 minute. In the meantime, I will open next task. Okay. No questions so far. So I will proceed with basic testing. Okay. So just a quick reminder, you had code that you had to test in your index.ts file, and you had index.test.ts file, which contained empty test suite that you had to fill with your tests. Okay, let's take a look at first case. It's named simple tests because tests should be really simple here. What do we have in this module? We have a simple calculator function that you are testing. What functionality it implements? First of all, it accepts some raw input, which has type raw calculator input. It's an object with three properties, A, B, and action, and it can be anything. That's why we validate this input. Okay, and here we also use type guard. So we validate that object has all necessary properties, that type of A is number, type of B is also number, that action is one of available actions, yes, enums can be iterated, sorry, not iterated, we can get keys, values, etc., just like from regular object. And if input is valid, we check action, and depending on action, we perform some arithmetic operations over numbers. So we can make addition, subtraction, multiplication, division, or exponentiation. If action is still unknown, then we throw error. It's impossible here because we check that action is valid action. So this code would not be executed, but it's still good to have a default case for switch condition, just in case. If something is changed, you will know by this error that you didn't handle some specific case. Okay, so I will put it to the right side, and at the left side we have tests. Okay, so you had empty test cases like should add two numbers, subtract two numbers, multiply two numbers, divide two numbers, exponentiate, return null for invalid action, return null for invalid arguments. And for some reason, Susan decided to use random numbers for each test case. From my point of view, it's not correct, and I will explain why. First of all, relying on some change in external APIs, even if it's inbuilt in JavaScript, makes test flaky and unpredictable. So you don't know which number you will have in your test suite. Plus, maybe here it's not that critical because, okay, we have mass round and null case is handled, but sorry, not null, zero case is handled. But people often forget about the fact that mass random can return zero sometimes. It's a rare case, yeah, but it can return zero and it can return one. And sometimes people forget about zero, and it leads to unpredictable behavior, which is hard to reproduce, because maybe they do some logical check for the value, and if it's zero, then logical context it's a false value, and test fails because of unknown reasons. Plus, from my point of view, you should explicitly pass some value to the tested function, and you should be able to read what result is expected. So test should be human readable. And in this case, I don't know what is passed inside of simple calculator call. Okay, I got it that it's some random number, and probably it's from 1 to 100. I don't know. I don't want to perform all those calculations in my mind. Okay, I want to see something like simple calculator A equal to 2, B equals to 3, action add, so I expect 5. Okay, so and you can see that the problem is that you have to re-implement tested functionality in tests. Okay, so instead of writing something like add 2, 3 equals 5, you have to implement add AB to equal A plus B. So we have A plus B here, and you have to re-implement it inside of the tests. So it's not very good. And also, if we are talking about some theory, it breaks tests isolation principle. Okay, we have this first acronym for unit tests, and it breaks I, isolation. So tests should not rely on some external API calls, external factors, and so on. So our tests are not isolated. I have one assumption where it comes from, because, well, if you will take a look at my repository, namely at basic.js, I have some auto-generated tests here, maybe. Uh, Yeah, it comes from here. And I have auto-generated tests here and in some other test cases, but why is it correct here and why it's not correct in real tests? I did it on purpose because, well, if I had just maybe 2 or 3 test cases with no numbers, no, you can hack tests like, okay, if you could just write multiple if-else inside of your functions that you implement depending on the test case, and then you could pass tests without really implementing necessary solution. So it was done because multiple people, I don't know, thousands of people, they sent solutions for auto check. Nobody is looking at it by the eyes, so it was made in order to make this a bit harder for students to hack the tests. But if we are talking about writing real tests that are useful, you shouldn't do that, definitely. Other stuff, okay, we perform different operations. Return null for invalid action is okay. But probably you should do one more thing. You check that argument B is invalid. Probably you should do vice versa as well. And maybe it could be done differently. So you could just maybe now. Okay. And you can put ABC for A and provide B as correct argument. So in this case, you covered all the edge cases, you covered all the arguments. This is how it could look like. Okay, let's take a look at original implementation again. Sorry. Check out this. Let's take a look at table tests. Okay, here stuff is even worse because what I wanted you to do here is just put your test cases in form of table tests, and after that and check that if you have some test cases that differ only on input and only in input and expected output, then you do not need to write it multiple times. By the way, a student did it here. Okay, probably we could yeah, okay, we have test cases in different forms. Yeah, I prefer this one where we use array, but you also can use template string. It's really up to you. But for these auto-generated tests, I have the same concern as on previous file, because these tests are not clear. Okay, I have to check it thoroughly, what's going on here. They are not very human readable. And also eval is very bad choice for using in your code, okay? Because it evaluates everything that passes into it, and it can be something very bad. So please, no eval, no auto-generated values, no mass random. If it was me who confused you, I got it, but use cases are different, okay? And I already explained that. So those test cases are correct. The only thing is that it should be done not only for incorrect input, but also for all other actions for valid input. But yeah, it's a good idea to separate cases for invalid input and for valid input. So it would be more readable. Okay, let's take a look at the next file. We have error handling here, and we have multiple functions that resolve value asynchronously. We have functions that throw errors. We have functions that rejects promises and rejects promises with custom error. And we have tests for it. Okay, for resolution of value, everything is fine, but once again, please, no mass random, just resolve some simple value. You don't need to use random value here. For throwing errors, it looks like correct tests, because here we checked two cases when error message is provided, and you can use this expect to throw syntax ingest for this case. Throw custom error, okay, we check that we not just thrown errors, that we thrown specific kind of error, okay, it's also very good. About this case where custom error is rejected. In general, this code works because promise is rejected pretty soon, but to be honest, this top level async await function doesn't wait for this promise to be rejected. Okay, so according to the documentation, and by the way, in Node.js native test runner, it works similar way. You should either use async plus await to await for this promise. Okay, this is one example of correct implementation, and another is to remove this async and to return this value. because when you use this resolves, rejects, and so on, it already returns promise. And you only need to return it from your test callback. So it would be waiting for it to resolve or reject. So both options are correct, but not this one, where we use async without return statement. It's not correct. Everything else is fine. Okay, let's take a look at uh, testing class. We had a class which represents a bank account, and you can do some operations like get balance, deposit some value, so it adds some number to your balance. You can withdraw, sorry, I'm not really good at pronouncing this, some money. So if you try to get more money from your account that it has, you will get insufficient funds error. Otherwise, your balance will be reduced by withdrawal amount. And also, you can transfer some amount of money from one account to another account, and you can fetch balance remotely, which gives you random number from Ladesh, and you had to try to control it. And also you can synchronize balance. This is a function this is a method that uses another method, fetch balance, inside of it. And in case if balance is null, you get synchronization failed error. So in order to simulate it, you get from fetch balance either number or null. So you could control what random returns to you and cover both cases. Okay, let's take a look at what was implemented in tests. I will close all this stuff. First of all, should create account with initial balance. Okay, we have some initial balance, it's 100. We create bank account with it. And then we have bank account get balance to equal initial balance. It's correct. I have some minor concerns to this implementation because, well, if you don't plan to execute this method, maybe it makes sense to check for property presence, okay? Maybe once again, you've seen this in testing repositories like basic.js data structures, somewhere else. It was done for more readable message to students who broke sorry, I accidentally moved run debugger. It was done for those students who accidentally break project structure, and they can see that they missing some method that should be present in class. Only for this case. Here we call bank account get balance. Okay, so if get balance doesn't exist, this test won't pass because it will throw error, and error value will not be equal to initial balance. So all these checks are excessive. You can skip it if you plan to call a specific method. So this should be removed. This is correct. We try to get more than we put to our balance. Okay, if we try to transfer more than balance, then we also have to get insufficient funds error. Once again, this checks for that from bank account and to bank account are instances of bank account is not correct. Okay. Maybe if we had another test, it would be fine to have it there, but here we only had to test that functionality that test case title covers. So if it should throw error, then you call method that should throw error and check for error. Nothing else. Okay, error on transferring to the same account is also fine. Transfer amount. Should deposit money is probably also fine. Okay, what was really incorrect? Let me take a look. Yeah, those excessive checks, they should be removed here as well. Yeah, I left comment here. So here we deal with a method that depends on another method call. It often happens that one class method calls another method. And here student just explicitly assigned his mock implementation of this method to instead of real one. Okay, it can be working like this, but if you want to mock the method, Jest has a very nice API for this. It's Jest spy on, and then you can provide your object and method name. And then you will be able to track calls of your fetch balance, because you may need to check internal API call. Okay, what do I mean? I mean that synchronize balance calls fetch balance. Okay, it can call it with some argument. I don't know, maybe we have this some number here, and fetch balance is called with this number. Okay, and we may need to check that when we call synchronize balance, then under the hood it calls fetch balance with the same number that it was provided as argument. Okay, with your implementation, it's very problematic to check it, because you need to implement some custom code that will write down argument of your mock function somewhere in your test, and then you will need to check that it's the same number that you provided to your mock function. Okay, but Jest Spice, they have a native API for this, and this is how you can track calls to underlying functions. So assignment like this one is not correct. Plus, you could also test. You could also mock a random function if you were testing fetch balance, but probably fetch balance we do not test it separately. Should remember if case of request didn't failed. Have property to be defined. If request didn't failed, okay. Here is the test where we had to mock a random function. Okay, so resolves to be defined. Not very correct. Okay, let's move on. Let's move on. Here we have partial mocking. We have functions mock1, mock2, and mock3, and we have functions that shouldn't be mocked. And it logs into console, I am not mocked. So test had to check that all other functions are mocked, but initial function is not mocked. Okay, so yeah, here we can use just require actual API. And here you provide original module, and after that you use assignment of just functions, just mock functions to the properties of this module, exported properties of this module that you need to mock. So yeah, everything is correct here. And also, after all, we unmock this module. And yeah, also here we use correct method. We use just spy to spy on console log, and we check that, yeah, mock functions were called, but console log spy were not called. By the way, probably those mocks you don't need to do mock restore because it's done automatically, if I'm not mistaken. So across tests, these are different spies. Probably you don't need to do it. And you can check that unmocked function still logs data into console. Okay, good. Everything is fine here. I have no concerns. Okay, here we had to mock some Node.js functionality. So one function reads file asynchronously using join exist sync and read file API calls. And also we have two functions that call their callback by timeout and by interval. Let's take a look at the tests. Here student used partial mocking API, which in general it's correct because well, if you need some other functionality from module remain untouched, you may mock only, you can mock only specific functions, but for simple cases like this one, okay, you can see that you import only exist sync from fs, you import only read file from fs promises, you import only join from pass, you don't use anything else, so you can just do something like just mock pass, okay, and in your test you can define mock implementation of your mocked function, and that's it. You don't need to do partial mocking, it's excessive from my point of view. Okay, in before all, we use fake timers. After all, we use read timers. After all tests are passed, and we clear timers between the tests. Probably, I'm not sure that you need to clear timers after each test. First of all, it has to be before each, because it's better to clear everything before first test was started. And also, I don't get why do you need this get timer count here. Okay, test case title says should set timeout with provided callback and timeout. You can see that your function, this only calls set timeout API with callback and timeout value. So you need to check that this API was called by with this timeout and callback value. So this is how fixed test could look like. You just have your spy. You call your do stuff by timeout function with mock callback and mock timeout. And then you check that set timeout spy, which spies on calls for set timeout API, was called with mock callback and mock timeout. And that's all. Yeah, and also you don't need to run timers to check that callback was called. It's done in scope of another test. Please stick to test case title. You should test explicitly what is requested in test case title. Yeah, because we have this should call callback only after timeout. And this is done correctly. Okay, you provide mocked callback. To do stuff by timeout, you check that it's not called immediately. After that, you advance your fake timers by timeout amount. And after that, you check that mocked callback is called. Probably, I would suggest you to recreate this mocked callback inside of each test, just to avoid this mocked callback, mocked clear, but it's really up to you. Okay, let's check interval function. Same concerns as for do stuff by timeout. Okay, if you need to check that set interval was called with specified function and amount of milliseconds, then you need to check only this, not that it was called. Yeah, I remind you that it could be done like this. Create spy and check that it was called with specified arguments. You could also check that it was called once, just in case. Okay, about callback multiple times for set interval. In general, it's correct. We check that initially it was not called, then we advance timers by interval amount of time, and then we check that after each advance of timer we get more and more calls. But I have minor concern here. To have been called means that it could be called any number of times. Okay, so if here your function was called twice, which is incorrect according to its implementation, but theoretically it can be, like this because you can check that your function was called twice, 2 times. Then this test would not fail and it would still pass. So to have been called times 1. And this is really better, it's more specific. What about should call join with pass to file, expect pass join not to have been called, read file asynchronous to have been called with. This to have been called check is redundant because you check that it was called with their name and pass to file. So if you check it here, you don't need to check it here. Return null if file doesn't exist, just Pion fs existing mock return value false, okay, not have been called, to have been called, result to be null, okay, it's correct. And here's the same, just Pion for mocking modules. But if you use something like SWC jest, this will not work correctly. So mocking whole modules using jest Pion is not the best tactic. It's better to do something like this. Import join from pass, mock pass, okay? And after that, you can, sorry, just Pion pass. You can do something like join as just mock return value, pass to file. And here you avoid this mocking whole module, and if you will apply some optimizations like SWC jest, it will still work correctly. Okay, let's move on. We have functions that gets data from API. It's wrapped, it uses Axios external library, and it's wrapped into throttling decorator from Ladesh. So this function is throttled. And you had to unpack your function. Yeah, you could mock Ladesh and disable throttling decorator. You could also check that your function is actually throttled instead and advance some timers to avoid extra API calls and check that it works correctly. But okay, unpacking your function from throttle decorator is also fine. So we have mock get. And for this, you don't need to use promise resolve API call. You can just do something like, okay, it's mock implementation, relative pass. Okay, actually here it's correct, but if you just need to asynchronously resolve some value, you can do mock resolved value, and here you can provide your value just in case if you don't need to mock whole implementation. And also we can spy on Axios create and check that Axios create is called with specific arguments. In general, I looked through all these tests. They seems to be mostly correct, but the only problem I've seen that checks are duplicated across the tests. Okay, so you have tests that says it should create Axios instance with provided base URL. You tested it here. Okay, so you do exactly same stuff here and you don't need to test it again because test says should perform request. So you need to check only the part that is about request. Okay, should return response data, you can only check response data. You don't need to multiply all these checks because otherwise, why do you need multiple test cases here? You can just test it in one test case, which is also valid option, but if you have 3 different tests, they should test different things. Okay, and let's move on to the last thing. It's about generate linked list function, which generates object represented linked list. This is data structure that looks like this. So you have your node, which refers to next item in linked list data structure by next property. And at the last level of nesting, you will have next null and value is not necessary to be null. You just have next null, so it means that you don't have other value. And student tested it like this. He tested it for specific properties, but from my point of view, it's also excessive, because if you do stuff like this, expect linked list to strict equal to some shape, then you test everything what you have here. And if anything changed, then this test is failed. So you don't need to check for specific values one by one. You can check for specific value only if you don't need to test whole object, only if it's important for you to check that for in some place you have your dedicated property. So it's excessive, plus you do not use values, sorry, you use values, but you don't use standard linked list from values constant outside of this test. So please follow this pattern. If something is required by only one test or only inside of single test, then you should move it inside the test and not put it in upper scope. So you should put here only reusable things, namely values, because you used it into test. All other stuff is correct, so you can use this expect linked list to match snapshot API. So if snapshot is not generated, it will generate it, and then it will compare result with snapshot. Snapshots are stored inside of files index.test.snap. It has some specific format. And that's basically it. So it's about basic testing review. Maybe you have some questions for this task. I will take a look at live streaming channel. If not, we can wrap up. Okay, I see that no one is typing, so I think we can finish the stream. So good luck with next WebSocket tasks. I will share task issuance from previous iteration with you in announcement channel, just as always. Okay, thank you for your activity and staying here. Bye bye. Have a nice evening.